Welcome. Look, we're all swimming in an ocean of information, right? The real trick isn't just having data, it's getting answers out of it. We're all sitting on these huge, messy data piles, and today we're going to see how a language like SQL acts like a superpowered magnet, pulling the exact answers we need right out of all that noise.
So picture this. You've got a spreadsheet with thousands, maybe millions of rows. Your boss comes over and asks for just one number from it. What are you going to do? Spend the next 3 days with a calculator squinting at the screen? No way! There is a much smarter way to do this.
To get there, let's think of ourselves as data detectives. And what does every good detective need? A solid set of tools. So today, we're going to start filling up your toolbox with the 5 most critical SQL tools for summarizing data. Seriously, these are the absolute workhorses of data analysis.
And here they are. Now, they might look pretty simple, but don't let that fool you. They are incredibly powerful. With just these 5 commands, you can instantly answer questions like, hey, how many customers do we have? What were our total sales last quarter? What's the average product rating? Or even, what was our single best and worst day for sales? They are the foundation for pretty much every data question you'll ever ask.
All right, enough talk. Let's get our hands dirty and put one of these to work. So let's say we have a big table of employees, and each one has a salary listed. The question is simple. What is the average salary for the whole company? Looking at our new toolbox, which tool do you think we're going to grab?
And here's the magic. Just look how clean and simple that is. It almost reads like a normal sentence, right? Select the average salary from the employee table. That single line does all the heavy lifting. No messy formulas, no manual work, just one clear instruction.
And boom, just like that, you get your answer. The database scans all those thousands of rows in a split second and spits out this one precise number. That is the power of what we call an aggregate function. You've just taken a whole mountain of data and boiled it down to a single, valuable insight.
Okay, that's really cool, but what if one big summary for everything isn't quite what you need? What if you need to slice things up and look at smaller categories? Well, it's time to add our second tool to the box, the sorter, or as SQL calls it, group by.
So here's our next puzzle. We don't want the total population of the whole world. No, we want the total for each individual country. Our sum tool is great, but by itself, it just lumps everything together. It needs a little helper to sort the data into piles first.
This is what our data looks like to start with. Just a long, messy list of cities. You've got cities from Afghanistan, AFG, all mixed in with cities from the Netherlands, NLD. To get the totals, you'd have to go through line by line, find all the AFG rows, add them up, then start all over again for NLD. That is just way too much work.
And this is where group by saves the day. The way it works is actually pretty cool. Before sum even starts adding numbers, group by jumps in like a super fast mail sorter. It says, whoa, hold on, let's get organized first. It makes a virtual pile for AFG, another for NLD, and so on for every single country code it finds.
And here's the beautiful result. After everything is sorted into those neat piles, then SQL runs our sum function on each pile one by one. And what we get is this perfectly clean, summarized table. We've turned a chaotic list of cities into a crystal clear report.
Now listen up, because there's one golden rule with group by you absolutely have to remember. Anything you ask for in your select list has to be one of 2 things. Either it's the column you're grouping by, in our case country code, or it's one of those summary tools, like sum. And it makes total sense if you think about it. You can't ask for the total population by country, but then also ask for the name of a single city. The database would have no idea which city name to show you.
Okay, so we can summarize and we can group. What's the next power we need? Well, we need a way to filter those groups we just made. And that brings us to tool number 3 for our toolbox, the group filter, which SQL calls the having clause. So we've got our nice, tidy list of countries and their total populations. Great. But what if our boss only cares about the really big countries? We need a way to tell the database, hey, after you're done grouping and summing everything up, only show me the groups that are above a certain size.
Now, this is a spot where a lot of people get tripped up. You might think, filtering? Isn't that what where's for? But there's a huge difference here. Where filters individual rows before any of the grouping happens. Having filters the finished groups after all the summaries are calculated. The best way to think about it is this. Where is like the bouncer at the door of a club checking IDs one by one. Having is like the manager inside looking at the full tables and deciding which groups get to stay for the VIP party.
The key here is to realize that our filter, that sum of population number, doesn't even exist until after Group by has finished its job. You can't filter on a number you haven't calculated yet. That's why we need having. It patiently waits until all the summaries are done and then asks, okay, out of these final results, which ones pass my test?
Okay, you've got the main tools down, so now it's time for a pro tip, something to help you avoid a super common mistake. We're going to talk about the null trap. It's a sneaky little issue that can give you completely wrong answers without you ever knowing something went wrong.
Let's say we want to figure out the total compensation for all employees, salary plus their bonus. This query looks totally fine, right? For each person, add their salary and bonus, and then just sum all of those totals up. Seems simple, but this query is hiding a really dangerous trap.
If you actually ran this, you'd probably get a number that seems way too low. Or maybe you'd get nothing at all. So what on earth is going on? Why is this simple little piece of math failing so badly? Well, the answer is one of the trickiest concepts in any database.
The bad guy here is something called null, and it is absolutely essential to understand this. Null does not mean zero. It means we don't know or this value is missing. You know, maybe a new employee doesn't get a bonus yet, or someone just forgot to enter the data. Think of it as a black hole where a number should be.
And here's the trap. In the database world, any math that involves a null just becomes null. So if an employee makes $50,000 in salary, but their bonus is null, then $50,000 plus null just equals null. That person's entire compensation gets wiped out before the sum function can even see it. It just vanishes. So how do we get around this? We have to be a little bit smarter. We let our aggregate functions do the hard work first. You see, the sum function is smart. When you tell it to sum bonus, it automatically knows to ignore all the nulls and only add up the real numbers. So we just apply that same logic to each column all by itself.
Which brings us to the correct way to write this. We tell SQL, first, give me the total of all the salaries you know about, then give me the total of all the bonuses you know about, and only after we have those two safe, clean numbers do we add them together. It's a small change, but it's the difference between being right and being dangerously wrong.
And there you have it. You've just added 3 of the most powerful concepts in SQL to your data toolbox. You now have the power to take a massive, chaotic table and summarize it, slice it up into useful groups, and filter those groups to find the exact insights you're looking for. The data is waiting for you. The only question left is, what story are you going to make it tell?